All right, guys, we're going to divide polynomials. We're going to divide today two different ways. Okay, this is a division algorithm that you're used to. Basically says when you divide two polynomials, you get another polynomial, q of x, which stands for a quotient, and r of x, which is the remainder. And of course, the remainder is the degree is less than what you started. So basically, the dividend is the divisor times the quotient plus remainder. That's the algorithm. That's called the algorithm. That's how you do division or how you check division. All right, so we're going to do one here. This is going to be long division, and it's going to work just like long division with numbers. And you got to hang in here with me here as I get through this thing on this iPad. So let me get this copied down here. Probably should skip space there. I'm going to skip space in between my x to 4. There's no x cubed term in my dividend there, so I'm going to I'm going to skip space where the x cubed term would go. Put the negative 3x there and a plus 1 there. Okay, so as I start to do this, what I'm going to be looking for every time, I'm going to change colors, is I'm going to look at the first term out there and the first term in there. I'm going to think, what do I need to multiply that first term outside by to get the first term by inside? In this case, I would need a 4x squared. So I'm going to take the 4x squared and multiply times everything on the outside. 4x squared times 2x squared is 8x to the fourth. 4x squared times x is negative 4x cubed, and 4x squared times 2 is 8x squared. Now, I'll do something a little bit different here than most teachers do. Instead of just doing straight up subtraction right here, I'm going to say this thing called draw the line, change the sign, which means I'm going to change that to minus, change that to plus, change that to minus. So I'm just going to add. Like, that's gone. I'm going to get a positive 4x cubed and minus 2x squared. Then I'm going to bring down that next term, that 3x. Then I'm going back where I started from. I'm going to start to look at the first term outside and the first term right here and figure out what do I need to multiply the 2x squared by to get 4x cubed, and the answer would be it needs a 2x. I'm going to take the 2x times everything in the front, which is going to give me a 4x cubed, a negative 2x squared, which is nice, and a plus 4x. All right, now I'm going to draw the line, change the signs. Instead of subtracting right here, I'm going to change all the signs and add. Change that, change that, change that. Those are gone. The x squareds are gone too. And that just leaves me negative 7x, and I'm going to bring down the plus 1. Now, here's what I noticed. If I look at the negative 7x down here, there's nothing I can multiply that 2x squared by to get negative 7x. So that means I'm done, which means this right here represents my remainder. So the way we're going to write our quotient and our answer is we're going to put in remainder, I'm going to go 4x squared plus 2x. That's the quotient. The remainder is negative 7x plus 1. So I'm going to put the negative 7x plus 1 over the dividend, which is 2x squared minus x plus 2. And finish up just like that. So I'm going to write my answer just like that every time I do a division. Goodness, that was good. That's long division. The better of the two division types is called synthetic. Synthetic is a quicker way to do long division, but here's the catch. You're only allowed to do synthetic division when you're dividing by a first degree binomial. It's got to be a binomial, meaning two terms, and the degree must be 1, like x to the first power. If I said x squared minus 3 instead of x minus 3, I would have to do long division. Synthetic works like this. I'm going to put the coefficient of these numbers right up here. Notice I put a 0 because I was missing the x to the 0 term. And in I'm going to call this a box. In the box, I'm going to put a 3. It's actually the opposite of what's in your divisor right there, or whatever makes that 0, however you want to look at it. And then the process works this way. You start out bringing the first number down below the line. Bring down the 2. Every time you bring a number down below the line, you multiply by what's in the box. 2 times 3 is 6. You put it underneath the next number. Then you add. You always add. You bring it down below. When you bring it below, you multiply by the 3. That'd be negative 3. Then you add. Then you multiply by the 3. Then you put it there. Then you add. Negative 4. I always put a little circle or something around that negative 4 because that represents my remainder. Now your quotient are these numbers right here represent the coefficients of your quotient. Okay, so I'm going to have a 2, a negative 1, and a negative 3. Now because I divided by 1x here into 2x cubed, my quotient is going to start with a 2x squared. Here's the rule for that. Your quotient's always going to start 1 degree less than what you started with. So it's going to be a 2x squared. The negative 1 is going to be negative 1x, and the minus 3 is going to be minus 3. So that's how my coefficients work. The negative 4 is the remainder. So I'm going to put a negative 4 over my divisor, which was x minus 3. And there you go. But the next thing we got is the remainder theorem. And the remainder theorem basically says if you want to find a value of p of c, meaning let's say this, let's say you want to find p of 3, all right? And they give you this function. They give you a function like p of x is 3x cubed minus 2x squared plus x minus 1, something like that. And they want to find p of 3. Instead of having to plug the 3 in everywhere, you can do synthetic, and whenever your remainder is, because it's called the remainder theorem, is the value of that function at that number. So let me show you one here. All right, it says let p of x be all this stuff, and it says find p of negative 2. Now, the quickest way to do this is called, the remainder theorem is also called synthetic substitution. So I'm going to put negative 2 in the box, and don't forget your 0 where the x squared is supposed to be. And I'm just going to work this out. So I'm going to go pretty quick. I'm going to bring the 3 down, multiply, add, multiply, add, multiply, add, multiply, add, multiply. Gives me 5 for remainder. Now what that means is if I were plugged in negative 2 for all the x's, I would get positive 5. Really quick way to substitute. It's called the remainder theorem. Whatever your remainder is, same thing you would have gotten had you plugged in negative 2 into all those x's and done all that work. Okay, last thing. Last thing is called the factor theorem. C is a 0 only if x minus c is a factor of p of x. And the way you can tell something is a factor is if the remainder is 0. So if you do like p of c, I meant to put a c right there, p of c, and you get 0, that means there's no remainder, which means it was a factor. So that's how you can tell if it's a factor or not. All right, this one says show that p of 1 is 0. Basically saying show that p of 1 is a factor, 1 is a factor, and use that fact to factor it completely. So what I'm going to do is I'm going to put 1 in the box. 1, 0. Don't forget the 0. And the reason, again, I put a 0 there is because there's no x squared up here. Okay, you got to have every exponent represented. And I should get a 0 at the end according to what it says up here. So I'm going to bring the 1 down, multiply, add, multiply, add, multiply. And sure enough, I do get 0, which means the 1 right there is a factor. And what that leaves me with, I started with x cubed, so that leaves me with an x squared down here. 1x squared plus 1x minus 6. Sorry about my phone, it keeps going off. And this had to factor completely. So if I factor what's down here, that would be x plus 3 and x minus 2. Here's where you're going to miss it if you're not careful. Don't forget what we started with. We started with the 1. That 1 as a factor would be written like x minus 1. So that's how you would factor it completely. All right, last thing, and probably the worst thing. It says find a polynomial of degree 4 that has those zeros, which means now you got to go backwards. So polynomial I'm going to do p of x is the negative 3 came from x plus 3. The 1 came from x minus 1. The 5 came from x minus 5. The 0 technically came from x minus 0. I'm not sure why that just moved. But instead of writing x minus 0, I'm just going to put x because that's the same thing as x minus 0. So I hate to say this, but your job right here is to multiply that stuff out. So I'm going to leave the x plus 3 for now. I'm going to do these last two and just do FOIL. If I do that, I get x squared minus 6x plus 5. I know I did that pretty quick, but I'm pretty quick. Okay, so now I'm going to do this. Leave the x out still. Actually, let's take the x through the second one. Let's make it x squared plus 3x. Okay, I distributed that. Have x squared minus 6x plus 5 still. And now to multiply these two, I'm going to take the x squared all the way through the second parentheses first. Make it x to the 4th minus 6x cubed plus 5x squared. Then I'm going to take the 3x through, this 3x all the way through. Give me 3x cubed minus 18x squared and plus 15x. And then what I'm going to do to finish up, to write my polynomial, I'm just going to add the like terms. So I have x to the 4th. I've got these two. That's negative 3x cubed. I've got those two. That's minus 13x squared. And I've got that 15x at the end. And there it is. Okay, that's the most work you're going to have to do is when you go backwards, believe it or not. So quite a bit of stuff today. Remember division, synthetic division. Don't forget what the remainder means, how to factor stuff, and then obviously if they give you the answers, writing the polynomial. So quite a bit. We'll work on tomorrow. See you then.